Okay, here we're going to go over numbers 13 and 20 from Formative 7a. This will help you with inverse trigonometry, recognized by standard M48.3. So one of the biggest pieces is making sure you understand what this question is asking when you see this exponent of -1 next to the sign. This question is asking what angles have a sine of radical 3 over 2. So to answer that question, we'll go to the unit circles and we'll look for angles that have a sine of radical 3 over 2. Now you know that radical 3 over 2 shows up most often in the 30-degree triangles and in the 60-degree triangles. And if you look at each time we're going to base our answer off of reference angles that are near the x-axis. So the opposite side of 30 is 1/2, and therefore its sine is 1/2. So it must not be the 30s that we're looking at. Let's go down to the 60s. When I look at 60 degrees right here, I see that its opposite side is radical 3 over 2. The hypotenuse is 1, and so the sine of 60 degrees is the square root of 3 over 2. So that's one of the answers we're looking for. So pi over 3, because that's in radians, and then we put the plus 2 pi k, because that indicates that when we, yes, 60 degrees has, or 60 degrees, or pi over 3, has a sine of radical 3 over 2. But if I were also to rotate the angle another full 2 pi, I'd end up right back in the same place, and therefore I would have the same opposite side and the same hypotenuse, and therefore I'd have the same sine. That's why we put the plus 2 pi k after the angle. Now there is another angle here that also has a sine of square root of 3 over 2. Do you see it? Okay, here we go. It is this angle right here, because when we look at 120 degrees, we use this reference angle down here. Its opposite side is also the square root of 3 over 2. Its hypotenuse is 1. So the sine of 2 pi over 3 is also the square root of 3 over 2. So 2 pi over 3 plus 2 pi k. Those are the two answers we're going to be looking for, and that's letter A. Now take a second to think about what question number 20 is asking. Question 20 is asking, what angles have a tangent of -1? So back to the circles. And okay, we can look at the 60s, but the tangent of 60 would be radical 3 over 2 over 1/2, because it'd be opposite over adjacent. I don't think that's going to turn out to equal 1. We can look at the 90s, but even in the 90s here, remember tangent is opposite over adjacent. For the 0 degrees, if I put the opposite of 0 over the adjacent of 1, I'm going to get 0. 0 over 1 equals 0. I could try 90 degrees, but again, opposite over adjacent, so 1 over 0, that's undefined. So that's definitely not there. So we're not coming from the 90s. We're really coming from the 45s, because if you look at it, the opposite side of 45 degrees is the square root of 2 over 2. The adjacent side is also the square root of 2 over 2. When you put those two fractions over top of one another, because they're equal, you'll end up with the value of 1. And so let me verify the question again. We wanted a tangent of -1 though. So if we got to go around the circles again and say, okay, yes, 45 degrees has a tangent of +1 because the opposite and the adjacent are the same size, but we want to get a -1. So we're going to go over here to the second quadrant, and if you look at this angle, the reference angle for 135, you'll see the opposite is square root of 2 over 2. The adjacent is negative square root of 2 over 2. When you divide those, you're going to get -1. So one of our answers is 3 pi over 4, again, plus that 2 pi k. There is another answer to this one, and so if you look at 315, or 7 pi over 4, its opposite side is negative square root of 2 over 2. Its adjacent side is also positive square root of 2 over 2. When you divide those two numbers, you're going to get a -1. So the other answer is 7 pi over 4 plus 2 pi, that's not a pi, 2 pi k. Those are the two answers we're looking for on this one. Now try to practice the questions in the section below and see how you do with the answers.